Hi friends, today I am discussing about how to find valency and valency electrons and also the differences between valency and valence electrons. So, what is meant by valency electrons? Valency electrons are the electrons present in the outer shell. See, valency electrons are the electrons present in the outer shell. What is meant by valency electrons? The electrons which are present in the outer shell known as valency electrons. Okay. Next, what is meant by valency? Valency means number of electrons gained, lost or shared so as to make outermost configuration. Number of electrons gained or lost or shared so as to make the octet of electrons in the outermost shell. See, the number of electrons gained or lost or shared to make octet of electrons in the outermost shell. Octet means stable electronic configuration in the outermost shell. So, you know what is meant by valency electrons? Valency electrons nothing but electrons present in the outermost shell. Valency means the number of electrons gained, lost or shared to attain stable electronic configuration means octet configuration. Okay. Next, according to Bohr's atomic model, here between the nucleus electrons are present. In which shell how many electrons are present we don't know. Based on this 2n square formula, in K shell how many electrons, L shell how many electrons, M shell how many electrons and N shell how many electrons we have to find. K is equal to 1, L is equal to 2, M is equal to 3 and N is equal to 4. So, substitute these terms in this formula. 2 into N means 1 square means 2 into 1 is equal to 2. 2 into 2 square is equal to 4. 8. 2 into 3 square is equal to 2 into 9. 18. 2 into 4 square is equal to 2 into 16. Means in K shell maximum attained electrons are 2. In L shell maximum attained electrons are 8. In M 18 and N 32 electrons. So in K shell 2 electrons and L shell 8 electrons. Next M shell 18 electrons and N shell 32 electrons. These are the outermost electrons. If suppose we take example as sodium atomic number 11, atomic electronic configuration 1s2, 2s2, 2p6, 3s1. Here 2 shell K, L, M. 3 shells are present. In K shell attain maximum electrons how many? 2 electrons. And L shell attain 8 electrons. And M shell attain 18. M shell attains 18 electrons. Okay. Here 3 shells are present. This is the outermost shell. M is the outermost shell or valency shell. valency shell or ultimate shell. See, M is the outermost shell or valency shell or ultimate shell. Before the ultimate shell or outermost shell or valency shell known as penultimate shell. Penultimate shell. And before the penultimate shell known as anti-penultimate shell. Anti-penultimate shell. See, we take example as sodium electronic configuration 1s2, 2s2, 2p6 and 3s1. In this case, 3 shells are present. K shell maximum attained electrons are 2 completely filled, and L is equal to 8 electrons, 8 electrons completely filled, and M is equal to 18 electrons, but here in sodium only 1 electron is present. Okay, in this outermost shell is M, outermost shell also known as valency shell or ultimate shell, and before the valency shell or outermost shell known as penultimate shell, and before the penultimate shell known as anti-penultimate shell. Okay, this is the electrons arranged in shells based on Bohr's atomic model. We have to remember this formula 2n square. Okay, next we go to how to find valency and valency electrons. See here, element, electronic configuration, and how many electrons and valency we find now. Hydrogen atomic number 1 and configuration is 1s1. We find valence electrons. Before what we told about valence electrons, valency electrons is equal to outermost electrons. In this, how many outermost electrons are present? Only 1. In this helium, next atomic number 2. The element helium electronic configuration is 1s2 and the outermost electrons are 2. Next, this is first we know K, L, M, N. In K shell 2 electrons, 8, 18, 32 like that. So these 2 electrons, both hydrogen and helium belongs to K shell. Next we go for another shell. 1s2 is K shell and 1s2 is K shell. Next we go for L shell. In L shell how many electrons are maximum attained? 8 electrons. See, L shell 8 electrons. Here having 1 electron. So outermost electrons, how many outermost electrons are present? 1. Outermost electrons is equal to valence electrons. Next, beryllium 1s2, 2s2. In outermost how many electrons are present in outermost shell? 2. In boron 3 electrons are present. Carbon 4 electrons are present. See, in carbon 1s2 is K shell and this is L shell. L shell attain 8 electrons but here is 4 electrons. But valence electrons is equal to number of electrons present in outermost shell known as valence electron. So outermost shell 4 electrons are present. So we are writing 4. Next, in outermost shell 5 electrons. In oxygen 6. Fluorine. In fluorine how many electrons? 7 electrons. In neon 8. In sodium 1. 2. Magnesium. Aluminium 3. Silicon 4. Phosphorus 5. Sulfur 6. And chlorine 7. Like that, outermost electrons are known as valence electrons. We find the valence electrons up to chlorine. Then for argon, how many valence electrons? 8 valence electrons. And then potassium, 1 valence electron is present in outermost shell. Then for calcium, 2 electrons are present. See here, in chlorine, this is K shell and this is L shell and this is M shell. So like this we have to find valency electrons, then go for valency. Valency means how many number of electrons gained, shared or lost to attain stable electronic configuration, means noble electronic configuration. Noble electronic configuration means 2, 8, 8, 18, 18, 32, like that. So to attain stable configuration, hydrogen gain 1 electron or lost 1 electron is same. So valency is 1. Helium, it is 1s2 stable electronic configuration. So no gain or no loss. It is in stable form. 0. No valency, 0. For lithium, 2s1 is there. To attain stable configuration, how many in K shell, this is K shell, and L shell, how many electrons to maximum attain 8 electrons, but here only 1 electron is present. To attain stable electronic configuration, it is able to gain 8 electrons easy or lose 1 electron easy. It is easy to lose 1 electron. So valency is 1. Here lithium loses 1 electron. Here beryllium, except beryllium, magnesium and for calcium, this is not applicable because I will say later. Beryllium having 2 electrons, but it is stable. This has 0 valency, but it is not correct. Beryllium belongs to second group because this beryllium valency is 2. See friends, valency is equal to group number. Valency is equal to group number. The element belongs to group number, that is valency. So valency is equal to group number. Here boron is equal to 2s2 2p1. Here in this L shell, it is able to attain 8 electrons, but here 3 electrons only present. So we attain stable electron configuration, we gain 5 electrons or lose 3 electrons easy. Lose 3 electrons is easy. So boron valency is 3. And for carbon, to attain stable configuration, we want 4 electrons because 2p2, here 2p6 electrons are stable. So carbon loses 4 electrons or gain 4 electrons is same. So 4. And for nitrogen, 3. And for oxygen, 2. Because here 2s2 2p4, 6 electrons are present. In K shell, to attain maximum stable configuration, 8 electrons are present. So we lose 6 electrons easy or gain 2 electrons is easy. Gain 2 electrons is easy. So valency of oxygen is 2. And then for fluorine 1 and neon 0 because 2s2 2p6 8. Neon belongs to 8th group. 8th groups are noble gases. So to satisfy valency, every element attain stable electronic configuration as noble gases. So sodium valency is 1. Magnesium 0. Magnesium is 0, but magnesium belongs to second group, so its valency is 2. Except beryllium, magnesium, calcium, this concept is applicable to all elements. Okay. Next, aluminum. Aluminum valency is, see here, 3s2 3p1. 3 electrons are present. See here, it is in K shell 2 electrons. Next L shell 8 electrons. Next M shell, how many electrons? 2, 8, 18 electrons. It is able to easy 3 electrons. So valency of aluminum is 3. And for silicon 4. And phosphorus, see here 2. This is K L, M. In M shell, 18 maximum attained electrons are 18 electrons. So it is here phosphorus having how many outermost electrons? 5 outermost electrons. It is easy to lose 5 electrons or gain 13 electrons. It is easy to lose 5 electrons. So valency is 5 and sulfur 6, and for chlorine is, see here, sorry friends, this is valency electrons, we are writing valency. So to attain stable configuration, here 5 electrons are present, but 3p in p shell 6 electrons is stable. So phosphorus is easy to gain 3 electrons, sulfur 2 electrons, and chlorine 1 electron to attain stable configuration. And then for argon belongs to noble gases, so its valency is 0, and potassium valency is 1, and calcium valency is, here beryllium, magnesium, calcium is exception cases, 0 is wrong, and this valency is 2. So what I told, valency is equal to outermost electrons and group number is equal, valency is equal to group number. Hydrogen belongs to first group, so valency is 1. Helium belongs to 8th group or 0 group, so valency is 0. Lithium belongs to first group, so valency is 1. And beryllium, 0 is wrong, its valency group number is, beryllium belongs to second group, so valency is 2. Boron third group 3, 4, carbon fourth group 4, nitrogen fifth group, but from fifth group the group number is equal to, valency is, from fifth group valency is 8 minus 3 is equal to valency from fifth group. Nitrogen belongs to fifth group, 8 minus 5 is equal to 3. So this is the valency of nitrogen. From first group to fourth group, group number is equal to valency. From fifth group, valency is equal to 8 minus 3. That is the valency of that elements. Okay, right. Magnesium valency is 2. Aluminium belongs to third group 3, and silicon, carbon, silicon, these are belongs to fourth group. So nitrogen, phosphorus are fifth group. From fifth group it belongs 8, valency is 8 minus 3. So like that. Next I am going to explain and the second method. If the element contain valency electrons less than 4, the element contain valence electrons less than 4 means valency is equal to valency electrons. So we take one example. Here we take boron. Boron electronic configuration is 1s2, 2s2, 2p1. Outermost electrons are valency electrons. So here how many valency electrons are present? 3 valency electrons are present. What I told, if the element contains valency electrons less than 4 means valency is equal to valency electrons. So the boron having 3 valency electrons and its valency is also 3. Understood what I told? If the element contains valency electrons less than 4, valency is equal to valency electrons. Boron electronic configuration is 1s2, 2s2, 2p1. Outermost electrons are 3. So here valency electrons are less than 4 because boron attains 3 valency electrons and 3 valency. Next again I am taking one again example. One, see, carbon. Carbon electronic configuration 1s2, 2s2, 2p2. Here outermost electronic configuration having 4 electrons. Valence electrons having less than 4 is less than 4 means less than 4. valency is equal to valence electrons. Here carbon valency is 4 and valency electrons are 4. So like that. Next, another method. In this method, second type. If the element contain valence electrons greater than 4, valency is equal to valence electrons minus 8. Valence electrons minus 8. We take magnesium. Magnesium atomic number 12. We are writing electronic configuration 1s2, 2s2, 2p6 and 3s2. Here outermost electronic configuration is 2. The electrons which are having the element which are contains valence electrons less than 4. Valence electrons means outermost electrons. Here outermost electrons is 2. This is valence electrons less than 4 means valency is equal to valence electrons means to the magnesium valency is 2 and valence electrons are 2. Next we take another example. Phosphorus we take. Phosphorus belongs to phosphorus atomic number 15. Electronic configuration 1s2, 2s2, 2p6, 3s2, 3p5, 10, 15. So how many outermost electrons are present? 5 electrons. What we told? Valency electrons are greater than 4 means valency is equal to valency electrons minus 8. Valence electrons minus 8. So valence electrons, how many valence electrons? 5 minus 8 is equal to 3. So for the phosphorus 8 valency electrons and valency is 3. So we have to find like this. I am taking another example. Sulfur outermost electronic configuration 3s2, 3p4. Here valency electrons are greater than 4 because valency is equal to valency electrons minus 8. How many valence electrons? 6 minus 8 is equal to 2. So for sulfur having 6 valency electrons and valency is 2. 6 valency electrons and valency is 2. So this is the way to find valency and valence electrons. Next, valency electrons. The outermost electrons are 1, 2, 3. The activity of element is loses the electrons. So the element which loses electrons are metals. In the outermost shell 5, 6, 7 electrons contain. The element activity is gain the electrons. So the element which gains the electrons are non-metals. Its nature is non-metals. And the outermost shell contains 4 electrons. It shares electrons. So the element of the nature is metalloids. In the outermost shell, it contains 1 or 2 or 3 valency electrons. The activity of element is to lose electrons, and the nature of the element is metals. And the valency electrons are 5, 6, 7 in the outermost shell. The activity of the element is to gain electrons, and these are non-metals. And outermost shell 4 valence electrons are present means activity of that element is to share electrons, and the nature is metalloids. So like that we find valency and valency electrons, and now we are clarity in what is difference between valency and valency electron. So I hope you understand, friends. Thank you. Please like, share and subscribe.